Giri, we can start now. Giri, we are live.
Good afternoon, friends. Welcome you all to this distinguished lecture series on energy efficiency. As you all know, we have this distinguished lecture series on the first Monday of every month. This is the 11th lecture in this series. The objective is to bring you thought leaders from India and abroad to share with you their thoughts so that the overall capacity of the Indian industry and engineers become better in terms of overall energy efficiency concepts and newer developments. We are privileged to have today Dr. Rene van Berkel, Head of Regional Office in India of United Nations Industrial Development Organization. Welcome, Rene. It's our pleasure and privilege to have you speaking to us at this program. He heads the Regional Office of UNIDO in India. And as we all know, UNIDO works to foster inclusive and sustainable industrialization in its member developing countries. Dr. Rene has got more than 32 years of professional experience in industrial resource and energy efficiency, cleaner production, productivity, innovation. Also worked extensively in areas of social responsibility and circular economy. Dr. Rene is an alumni of University of Amsterdam and Wageningen University. Dr. Rene has, I have had the privilege of knowing Rene for more than 15 years. Since 1993, he has been instrumental in fostering adoption of cleaner production and industrial ecology in developing and emerging countries in both Asia and Eastern Europe. One unique thing about Dr. Rene is that he has worked at the interface of academia, government, and industry with equal knowledge and felicity in each of these areas. He has served in applied research and academic roles in the Netherlands and Australia between 1989 to 2008. He served as UNIDO's program lead on resource efficiency and cleaner production at Vienna. Under his guidance, the RECP became a major concept, which has become extremely popular, and resource efficiency and cleaner production centers are in operation in nearly 50 emerging and developing economies. Last few years, Dr. Rene has been leading and guiding UNIDO's activities in India and South Asia. Thank you, Rene. Thank you for your time and presence here. And apart from all that, Dr. Rene is definitely a thought leader and is extremely articulate in presenting newer concepts. Over to you, Rene. Thank you.
Thank you very much, Giri, and thank you to CII for inviting me. Let me see what I can share the content. I actually, I think you can see it. Is it fine? So now it's there. So I will speak about energy efficiency, even though I have a little bit of an issue. I'm neither an energy engineer nor an energy economist. So I'm a bit of a jack of all trades, talking about productivity and innovation in a broader sense. But of course, this is very relevant to energy efficiency. And so I will speak about the industrial energy efficiency. And I think some of the lessons might also be applicable to kind of buildings and transport sector. But the main focus is really on the industrial manufacturing sector. So as Giri mentioned, I represent UNIDO, the United Nations Industrial Development Organization. And just for those who are less familiar with UNIDO, our mandate is to promote industrial development in our member states, and particularly then around SDG 9, which is building resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. So the link between industry and innovation is very strong. And this inclusive and sustainable industrial development is basically along the tripartite goals of advancing economic competitiveness, safeguarding the environment, and creating shared prosperity, which in many regards are a mouthful, are quite abstract concepts. So I like to say that we basically need to look at industrialization that works for markets, so that we have products and services that are sought after in the market and have good quality, and that work for people, so we have decent conditions of work, we keep people and communities safe, and that also work for the environment and climate, which is then the subset that I will be dealing with this afternoon. In that, of course, energy is a key component, and I take a little bit of step back. I know this is now a little bit older, but UNIDO started its work basically on the industrial energy efficiency with the Industrial Development Report in 2011, which was pre-Paris, pre-SDGs and so on. But what was basically in there, as if I just take a few graphs, that it was observed that industrial energy efficiency is dropping, and you see here that it's dropping dropping over time. So this is basically your tons of oil equivalent, but $1,000 of manufacturing value. But you see it coming down in all income groups, but it's still by far the highest in the lower income and developing countries. So it came down, the energy intensity, but it's in developing countries still much higher than in the developed economies. And if we do a composite analysis of this, what drives this improvement in industrial energy efficiency, then there are basically two components. One is the structural change. So countries are changing the composition of manufacturing. So it's more going towards higher value add manufacturing and lighter industry. And that results in overall manufacturing energy intensity coming down. And that is actually the bigger part of it, is 12.5%. And then the technological improvements was 9.8%. Even though these data are now 10 years old, I don't think the picture has changed drastically. Of course, the numbers have, but the overall picture is clear there, that investing in energy efficient technology systems and process can provide environmental, economic, and social dividends, and is in that sense necessary for the green growth and for low carbon industrialization. What was also found there was that if you look at 2-3 decennia, then the industrial energy intensity in these graphs, which you see here, comes down by on average 1.7% per year on the long-term average. Of course, there's some peaks and troughs in there, but that seems to be there. And really the potential is quite clearly there to double this to 3.4% per year. And that is also the part of the SDG commitments to look at this. But the worrying figure is actually that concern is actually that the International Energy Agency is reporting now 2018, 2019 that this rate of improving energy efficiency is actually slowing down. So we need to find ways to reinvigorate and to accelerate progress on energy efficiency. So I want to do basically two components in my presentation here. First, I want to look a little bit at what I see happening now and comment on that, and maybe also share some UNIDO experiences. And then in the second part of the talk, I would rather go and then elaborate a little bit on more of what I see as horizons, where maybe energy efficiency can be done with a broader perspective of looking at resources and synergies. So the low carbon demand side strategy which UNIDO has is I'm basically looking for sustainable energy and energy security particularly in the energy intensive sectors and clusters. And we see that as a three-pronged strategy essentially. So we see energy efficiency, that is our concern, as improving the efficiency of energy used in industry. So basically that's around your specific energy consumption. But that needs to be in tandem with improving the resource productivity, or basically bringing down your specific water consumption, or your specific materials consumption. So if we use less stuff, we will also use less energy, and that drives then the transformation to energy efficiency and low carbon development. And of course, we need to bring this in sync with decarbonizing our energy supply, which is then maximizing the use of all appropriate renewable energy sources. And with renewables, I tend to include and also looking at waste heat that might be available. So renewables in a broader sense. And this, of course, we see increasingly this needs to be informed by improved energy management and energy planning, and where appropriate, maybe also look then at the energy storage as part of the solution to low carbon industry. So as I said before, I want to look at what I see happening is basically that we have three buckets of energy efficiency which are happening simultaneously and maybe consecutively in the specific units, but they are more or less happening in parallel. The first one is what I would refer to as kind of the improved, or I can also say a fix-up. So it's basically addressing all the issues that are kind of immediate energy losses, which can be remedied quite easily with low capital investments. I put there as an indicative figure, definitely not more than 10 lakhs, and in many cases much lower. Then I think there is a bucket of opportunities which are around the upgrade, so that there is a lot of energy efficient technologies available, which are by and large confirmed or are proven feasible, maybe not necessarily next door, but in a broader context considered feasible, and that require investment, but these are investments which are profitable, or which there's in reason could be afforded by it. So I would call that like the upgrades or the improvements which are there. And then the third bucket is the kind of the innovations, where there is a change of the basic technology or the processes, where higher capital investments are required, and where, of course, you would also have higher risk, but potentially also higher rewards in terms of deeper cuts of emissions, deeper cuts or deeper savings of energy. So if I look at some of these, what specifically can be done in these areas, then I think in the improving strategy, you see basically good returns without significant investment. And we can talk about it, and this talk has been the same for the last 25 or 30 years, but it's just not being practiced enough. And we sound like a broken record, but we still have to do this. Good housekeeping, know your energy use, switch off what's not productive, fix what needs fixing. So if there's one person once said to me in the old days, if you had a steam leak, that was a good sign, but because it meant that the boiler was operating. And we need to still get these perceptions around that this is a sign of that money is basically being lost. We still see compressed air being used to cool people, and this is not efficient. And this is a perception we see. It's common accepted that we go in the street, we see energy efficient street lighting, but it's switched on in the daytime. So we still don't have this mindset right that energy needs to have a productive application in that. So good housekeeping is there. Then the simple equipment modifications are there. Certainly, I think in traditional areas are insulation, heat recovery, which are really very well proven and also very cost efficient and not expensive. And the better process controls, I think, fits also in this category, where you say you optimize the set points, you look at your fuel air ratio, you look at your compressed air pressure, whether that's the right one, can that be moderated or modulated? How can we improve with the systems which we have? And I think the basic point is that we need to overcome the knowledge gaps and the attitude barriers, that energy basically matters for bottom line performance. I think the larger industries has basically come onto this, but many small and medium-sized enterprises do not yet make the connection between energy use and profitability, profits in the end. So just to share then one of the examples of what we're doing, that's the JEF4 project, which we do with Bureau of Energy Efficiency and renewable energy in selected MSME sectors. So we've, over the past years, have supported 12 clusters in 5 sectors. So I won't list them all, but dairy, foundry, ceramics, brass, and hand tools. And what we've done is we set up energy monitoring centers, or I would rather have said monitoring cells. So provide the associations with some monitoring kits so that you can actually go out and find out where the energy is being used, where energy is lost. Those cluster centers have supported 345 MSMEs, and they implemented then over 600 energy measures. They saved 10,000 or nearly 11,000 tons of oil equivalent and 63,000 tons of DHG. And that's an investment of 90 crore associated with this, with annual savings of 59 crores, which means roughly 18 months payback if you take the bold average. There might be some which are better and certainly also some which are worse. But this is not a lot of money if you look at this as 350 MSMEs going in there. And right now we are also with the support of the Green Business Center scaling this up to a further 11 clusters in 3 sectors, for which we have then identified these replicable technologies basically, and then trying to assist the enterprise to basically make an implementation plan. So we've already taken out the guesswork of what are feasible measures. We just want to get your implementation roadmap there. And for that we have over 1,100 MSME expressions of interest. So if I just take a few examples, so of the dairy sector, so if you take Amur, they save 50 lakhs annually by repairing just the compressed air leaks and virtually no cost, labor cost only. Invested 3.2 lakhs for condensate recovery, saved 7.2 lakhs, which is then basically a payback of 4 months. Gopal Dairy, they installed then the soft starters for the refrigeration unit, 2.9 lakhs investment to save that 4.8 lakhs, so it's also just 7 months. Dutsagar Dairy installed an variable frequency drive on ghee processing, 82,000 investment savings, 1.3 lakhs, so that's about 7-8 months. And Sumo Dairy then a plate heat exchanger for yogurt units, 4.2 lakhs savings, 8.6 lakhs, so that's 6 months. So we see that even in organized sectors, there are still many opportunities if we bring in this perspective of energy as a cost, and energy can drive your productivity. I want to take the opportunity, and right now what's happening, work that's happening is that we're putting these technology compendiums together. It's too small on the screen, but you might take inspiration of that, which is basically like 15, 20 key measures that can be taken in specific clusters. What is the kind of typical investment rate? What's the typical savings? And that can be promoted. I want to take the opportunity to also link then to work that UNIDO is doing globally on the Industrial Energy Accelerator, as it's called, which captures basically global best practices in industrial energy efficiency. And this takes a perspective on one hand on the energy management systems, basically 50001 ISO, and then also looking at the systems optimization, what is happening. And systems optimization is really saying that we should not just optimize the boiler, but we should look at the boiler along with the steam requirements, the steam traps, and all the controls which are there. So this focuses basically on motor-driven systems, industrial heating systems, and industrial cooling systems. If we just take from UNIDO's work on the energy management systems, which is basically has been a focus for 12 years, but this was after 10 years, you see the different countries where this was supported. And we come time and time again with, let me highlight this figure, 4 to 15% energy savings in companies in the first year of implementation of an energy management system with little or no capital investment. So this is my thing of improve or fix up in the first place. And then in terms of the system optimization, there are these booklets now available, which in this case I've just put on the motor system optimization. So it guides you through a set of questions to really analyze the performance of key components of the motor system and then optimize this. And then here also you see then that this has been rolled out in 18 countries, and you see the number of enterprises which have been taking this on. So these are all systems which are online and available. I would really encourage people to just glance through this and take this as a source of inspiration to move forward. Then I get to my second category, the middle basket, which is basically upgrades using efficient equipment and devices that typically have a higher investment cost, but have a good payback. And you think then a replacement of energy equipment is one of the key ones: boilers, compressors, furnaces, automation of energy and process controls with VFDs or with PLCs for industrial automation, and some modification of process equipment, but that's very specific. And then I think here the key point is to reduce the perceived investment risk and making appropriate financing available. We see that many of the MSMEs are getting access or are being exposed to these technologies, but not getting the level of confidence to invest, because it's just reliant on a vendor passing by and saying this is the best way for you to go, and tomorrow somebody else comes and tells a different story. So we need a more authoritative, quote unquote, and impartial advice that this is the way to go for certain sectors. And with that, we take out a little bit of the guesswork, and that improves the profitability, of course, of this. So here we have a project together with ESL and Ministry of MSME in promoting market transformation for energy efficiency and MSME clusters. And it basically works on a three-stage approach with this market transformation. First, to standardize the technology, so to come up with replicable solutions of what can be done in a cluster like Muzaffarnagar paper cluster. What are typical solutions? Then looking at aggregation, so can we bulk procure and get a price reduction? And then looking at innovative financing through ESL as ESCO contracts. So that's in 10 clusters which are around here. I will not go through that. So far, we've just done 20 replicable energy efficient technologies, and this is being trialed in 10 MSME clusters. So just to take a few examples of what has been, where the monitoring and verification has been done in Surat, So on the left-hand side, you see then the replacement of energy efficient with installation of energy efficient screw compressors rather than reciprocating compressors. So the target for the specific energy consumption is a reduction by 40%. And you see in the demo units that a little bit dependent on the load pattern, this can be achieved. But the one that the investment is 6.7 lakh and then savings 3.8, so that's less than half a year, 50,000 kilowatt hours energy saving. And the second one is a larger unit, 16 lakh invested, annual savings 14 lakh. So that's about, 10, 11 months, 190,000 kilowatt hours saved. The second example I want to give is on the PLC control on jet dyeing machines. And there, of course, our specific energy consumption target is 10%, but we see there are many other benefits being achieved by optimizing the jet dyeing, in particular water requirement, batch time, liquor ratio, and chemical requirements. So if you look at this just from the perspective of energy, then the demo one at 16 lakh investment, 14.2 lakh savings, 345 ton coal equivalent per year. So that's within a year. The other one was 18 lakh, savings was higher. Annual savings was lower, sorry, 17.9, but that means still a payback of 2 years. The differences in the payback are largely a reflection of how well the jet dyeing process was managed before the automation. So if the companies did quite well before, their savings are lesser than the ones which had more limited control. Then I get to the innovate category, so change to new process and new technologies, and that's the biggest issue is basically the uncertainty on the process, on the performance of unproven technology. And we can see that it's highly specific, but we can look at new processes. So a lot of emphasis now on additive manufacturing rather than deductive. This remove materials, so added physical instead of chemical, new technologies, new products. And really the issue is that we need to support the set of the innovation system. So we support identification, deployment, and commercialization of what is maybe more conceivable rather than proven technologies. Here we've done work on the Global Clean Tech Innovation Program, which was basically an accelerator program that supported market innovators to transform into startup companies. There were 26 startups that succeeded. They had a JEF grant of $1 million that was increased or matched by $7 million of investment at the end of the process. A project, 2 years later on, that has increased to $21 million US. So quite innovative. Some of the examples then here is Atomberg from Mumbai, I think, if I'm not mistaken. So they put basically a BLDC motor into a ceiling fan, and they bring down the energy consumption by at least 60%, from typically 70 watts to 28 or even less watts for a ceiling fan. The other example, which is quite interesting, is this Sumuk. The name pronunciation is a challenge, but basically they engineered what he calls a horizontal flame for cooking appliances, and that achieves 30% plus fuel savings in cooking in commercial kitchens, but it can also be applied in larger commercial furnaces. Taking this forward, we basically also take this towards the perception that we need in this innovation ecosystem to have both the product value enhanced. So that is basically getting an idea to prototype and that proving that it's valuable to the customer, and also create business value for the investor. So setting it up in an innovator, in a startup company that is worth investing in. And that is more the work that we do with the Facility for Low Carbon Technology Deployment, FLCTD, that we run with Bureau of Energy Efficiency, and where the Green Business Center is also an execution partner. So we offer their deployment support. So we have a technology challenge to identify early stage innovations with significant energy and GHG emission reduction potential. We have had traditionally three pillars: waste heat recovery, pumps and pumping systems, and space conditioning. And you see that over the last 3 years, we have selected 40 startup early innovators to support, and then bring the innovator and industry partner together for field trials with partial funding to basically demonstrate the innovation, but also validate the efficacy and determine the scale-up opportunities. Last year, we introduced 3 new technology verticals: industrial, Internet of Things, resource efficiency, and electric energy storage, but there's not yet any movement forward there. I think my system is speeding up. So this is one of the examples, the slip start synchronous run motor, which basically combines a hybrid motor for pumping, and that gives you a better operation efficiency and less motor starting currents, and it gives overall 30% energy efficiency improvement and smaller pump size. So if we assume 10% pump replacement in irrigation pumping, this would save 12,000 gigawatt hours of electricity use annually. So if these small things can ultimately make a national level a significant way forward. Second example is waste heat recovery from bulk milk chilling. So we basically capture the waste heat from bulk milk chillers to generate then hot water, which can be used in cleaning in place and improve then also the hygiene. With a typical system, you can then generate 500 liters hot water, which is enough to clean the equipment. And with 20% market penetration, that would save up to close to 40,000 megawatt hours electricity annually. This is done by Promethean Energy. Plus Technologies is introducing this thermal energy storage for chest coolers. So they basically put pouches with phase change material in the inside of a chest cooler or chest freezer, and that acts then to improve energy temperature retention and reduce operation of the compressor, and also cover up for periods that we have a power interruption. So with a chest cooler, they can be maintained 3.5 hours without power, and that saves 115 kilowatt hours per year. Chest freezer, it can even operate 16 hours without power and save then 27 kilowatt hours a year on a standard size chest freezer. So this equipment is very useful in the retail and other places where maybe your power availability is not so great. So we can also extend that with the thermal energy storage batteries for cold chain, which is done by Textile. You basically make these phase change materials, these batteries, which you put in a truck, delivery truck, and then you maintain cold storage for 8 to 10 hours. And that saves then diesel into the refrigeration truck. And at 20% market, this would avoid close to 9,500 kiloliters of diesel annually in India. This is Textile doing this. I think that this is basically my reflection on what we should do. We should accelerate each of the areas of basically fixing up, then improving, and then ultimately innovating. But I think that what I would also like to emphasize in the next 10 minutes or so is to focus on this, the opportunities for taking a wider perspective on energy as just one of the resource inputs to industry, and that opens then additional avenues for energy efficiency. And I will then highlight that from the perspective of industrial resource efficiency, which is basically saving energy by conserving materials and water or using better chemicals. Industrial symbiosis, so that's saving energy through multi-firm networks, or process innovation to look really for new innovative technologies. So I will share a few slides on this and some examples, maybe international examples, more as a source of inspiration that we need to think outside of the box of what we have as our energy efficiency toolbox. So on industrial resource efficiency, as I put here the graph from the water development report, it basically shows that most industries have a match between both being water intensive and energy intensive. The only outlier is the aviation industry, where energy intensity is much higher than the water intensity. So many industries are good opportunities for water savings, and that is the basic concept of resource efficiency and cleaner production, which you see in this diagram. We maximize the efficiency, the productivity of water, energy, materials, and basically we have less stuff to throw away into the environment, so we have less waste, less emissions, less effluents, and that improves then the factory environment. We improve well-being, which adds to resource efficiency. So this resource efficient and cleaner production then deals with the materials, the energy, water, waste, emissions, and effluents. And we have this global network that Gary was referring to in the introduction. So just as a simple example of some recent work that is with Kanpur, where we introduced some cleaner leather technologies. So we do this alternative unhairing process. We can basically reduce the salinity and effluent load by 30% through this hair recovery process, and this then saves a lot of energy in the wastewater treatment and in the water handling. Then with water conservation can be, and energy and chemicals conservation can be achieved by basically measurement and reuse of water. And then here we did also a little bit of solar air drying for the leather sector. This is materials which have then also been promoted to a kind of a standard guidance on sustainable leather manufacturing, which is being adopted by the leather panel, which is an agglomeration of international leather companies and buyers. So then I take it to the industrial symbiosis, so where we, or you might say eco-industrial parks, where we look at using waste from one company into another company, and that's the typical kind of eco-industrial parks, where we combine the resource efficiency in cleaner production at enterprise level with integration of energy and water systems and symbiotic exchanges, so where the waste from one company becomes an input to another company. And there's been quite extensive work done. Also, CII has been involved in some of this work to develop an international reference guides, which are listed here on eco-industrial parks, and also some practical tools in there. So just to give some international examples of what is achievable, and I take this one from Kwinana, where I was involved myself when I worked in Australia, which is a large resource-intensive industrial area near Perth in Australia. One of the things is their cogeneration plant, which basically takes the refinery fuel gas from the oil refinery and use that as auxiliary fuel for the steam turbine, and that basically provides then also steam to the refinery. With this flexibility of steam and power supply, the efficiency of the oil refinery is improved. They claim at times 6 to 8% efficiency improvement in the refining, which is a huge benefit there. And this is integrated in the state power grid as fuel efficiency. And then you have also the Kwinana water reclamation plant, which basically takes the treated sewerage and then puts that through ultrafiltration and microfiltration to produce low TDS water, which is not drinking water, but is a high pure water for industrial applications. And then because of the low TDS, you have less scaling problems and you actually improve the energy efficiency in all the boilers which are operating in the industrial park. Then another example I take from Ulsan in Korea, where they actually went as far of what they locally refer as a steam highway, which connects demand and supply of steam between different enterprises. So there's an oil refinery, chemical plant, and a power station, and a few waste incinerators connected. And this steam highway achieves now annual savings of $19.2 million and CO2 savings of 0.5 kilotons of CO2. So where the traditional view is that you can't transport steam over longer distances or more than a few meters, this is actually being constructed as a pipeline of almost 15 kilometers and is providing multiple benefits, energy efficiency, but also increased operational efficiency in the different plants. Then I think in terms of the innovation, I would like to highlight this, which came up basically out of the energy efficiency work in Denmark, which some refer to as the onion model, which is saying that basically we need to look at the energy service of why do we need energy, what is then the way of delivering the energy service, or the process, then look at the type of equipment and the efficiency, then the controls, the operation and maintenance, and good housekeeping. And what is the big challenge we observe is that with the energy efficiency measures, we don't drill sufficiently down into the process and the energy service. So we are dealing with the outer layers of the onion model, because that is where the replicability is for the energy equipment and the controls and so on. But the core processes, the core energy services are maybe not enough addressed. And we see now more emphasis in Europe and maybe Japan, Australia, on trying to get to the level of what is the energy service needed in the process and how can we innovate on that. And I think a particular strong example for this of different frameworks which are there is basically green chemistry and green engineering, which are not different from traditional chemistry and traditional engineering. The laws of thermodynamics still apply, but it's trying to apply this with a view of achieving different environment and sustainability outcomes. And that is then often reflected in these green chemistry principles, where design for energy efficiency is in there, but also using safer solvents, design for degradation, catalysis, in there. So I personally believe that that India can still capture an opportunity, given that the chemical and chemical synthesis is such a huge sector in India, to actually embrace this green chemistry and engineering. We saw on the GCEP, the Global Clean Tech Program, some examples. I will just put that there, basically around supercritical fluid extractions with carbon dioxide for done by Aspartica for different clothes, cumin, and so on, and also using that for the silkworm pupae, so what is left over after you extract the silk, you can extract their omega-3, which is added as a feed supplement. And then the other ones would be Cellzyme Biotech, which is engineered enzymes for antibiotic synthesis at room temperature and without solvents. And the solvents are really an energy consumer, because we have to create a vacuum to evaporate the solvents for the solvent recovery. So if we can do this synthesis at room temperature, we have many energy benefits. Maybe I'll illustrate that this is, of course, is then also has its applications in the different sectors that use chemicals. So particularly in like textile industry, we see now this whole issue of going to waterless textile dyeing, and then you see solution dyes for nylon, which reduce water consumption by 80%. So you basically put the dye in the extrusion of the polymer of the nylon, and you have fewer chemicals and CO2 emissions, lower energy consumption, and it's longer lasting as the color, as the fabric fades less. And the other example, I take a bit of pride because this is actually a Dutch company doing this now, and the larger scale is this supercritical carbon dioxide dyeing, where you basically use supercritical carbon dioxide for polyester dyeing and other materials, and you have zero water, zero wastewater. You don't need any process chemicals like levelers and salts, and you have 98% of the dye uptake. You can do this. Then also much smaller floor space, 40% faster, and you save 63% energy. So this was initially very much frowned upon by the industry, but now there are at least a dozen factories operating with this technology, and it's also being promoted as an alternative for going to circular fashion. I come to kind of a wrap up. So I think that if I captured my last 25, 30 minutes, I think that we need to accelerate and scale up the implementation of the known solutions, and that is by the improvement solutions. It's really about knowledge and overcoming the barriers to in attitude, and upgrade is really looking more at how can we unlever and de-risk the investment decisions, and innovators setting up the innovation system. And then on the other side, we need to also look at looking at conceivable solutions. So I'm using the term conceivable because I want to get away from just thinking about what is immediately feasible. If we don't never think about what is maybe conceivable, what we could think that we could trial and error do, then we have much more opportunities in this resource efficiency, symbiosis, and process innovation. And of course, this we need to across this and address barriers in terms of attitude, skills, policy, and financing. So with that, I probably keep it there. There's a number of websites here which we can also share later on, where some of the information is there on resource efficiency, the industrial energy accelerator, the low carbon innovation, the green chemistry initiative, and some of the work on the building back business from crisis. So thank you very much. I hand it back to you, Kiri and Kiran.
Thanks, Rene. Thank you. That gave a complete picture in terms of what your thoughts are on energy efficiency, what has been done, what can be done, and how that spills over into the broader agenda of resource efficiency, and also talking about many key elements, particularly on green chemistry and on systems in particular, which I liked a lot. There are quite a few questions, Rene, that have come in. Maybe I can group some of the questions and take your views and inputs on them. The first set of questions were predominantly on this post-COVID recovery, Rene, and I'm personally aware that UNIDO and you in particular have been doing quite a lot of work on the recovery of the small and medium enterprises post-COVID. There have been quite a few questions in terms of how industry will look at efficiency and productivity post-COVID. So would you like to share some inputs on your work, Rene, on that and your findings and what next?
Yes, I think this is quite a legitimate question, because the cash flow crunch is clearly on, and businesses are seeing it difficult to invest. But I think there's two parts to this. One is the fact that the times are not as rosy as they were before. So efficiency is even more on the agenda. So if you could barely afford to be inefficient in the past, now that the times are worse, you should first of all look at the efficiency improvement. So the case for efficiency improvements has never been stronger than right now in that sense. So I strongly believe that, and this is also, I think, what you and others, our partners, are finding, that now that there is businesses coming back to a little bit to some degree of normalcy, even though with high risk and high uncertainties, that businesses are saying, yes, we need to look at this energy component. The other part of it, of course, is that the investment opportunity has declined. So companies are finding it difficult to invest for just everything. So this is still a bit of the challenge. What we've done as UNIDO, we created this what we call B3C MSME platform, which is building back business from crisis, where we try to put a lot of this notions around manufacturing excellence and operational excellence into a kind of a simple roadmap for MSMEs to address while recovery from the crisis. And I think even though most businesses are back, have restarted and reopened, there's still a lot of value in there to look at manufacturing excellence. How do you deal with your financing? How do you deal with operations? All businesses have had to address the issue of becoming COVID proof in that sense. So a lot of emphasis on occupational health and safety, of course. And I think what is also, if you look at the bigger picture, then we certainly see also in the international community that the push for climate change and for circularity has certainly continued. And you've even hear some people saying that we've been woken up by this small bug and we created huge havoc. But wait to see what could happen if climate change happens, because that would be much more a systemic impact, which cannot be captured in one disease. So even some of the skeptics have turned around in that sense. So we will have to look at the implementation challenges, particularly finance. But taking this as a way forward, if we rebuild, then it needs to be a rebuild about efficiency, manufacturing excellence, to address the weaknesses which we had before COVID.
Thanks, Rene. There are a couple of questions on the improve aspect of efficiency that you covered, and I know you summarized it in the last slide in terms of acceleration. But the question that comes back, Rene, is India's efforts as far as energy efficiency is concerned has been there for several years. I mean, the first energy efficiency program in India started in 1970s. It has been over 50 years, and still we see a lot of opportunities in the improve and upgrade categories of
yes.
The areas of improvement that you have suggested. And of course, many of the UNIDO programs also talk about several successful case studies implemented in the improve and upgrade categories of efficiency gains. How do we mainstream it? I mean, what are your thoughts in terms of accelerating it? How do we make it a common practice across all industries, that we don't find any more opportunities for improve and upgrade anymore? We look at more of the innovate category of improvements.
Yes, this is quite a challenge, and indeed, I mean, I myself was involved 25 years ago, and we were also talking about fuel-air ratios and the same things on compressor leaks and compressed air leaks and so on. So it seems to be certainly a never-ending story on that, and that is. That to a certain extent is not avoidable, because there will be people who come new to this, new factories. We are new to this, but we haven't seen this knowledge being mainstreamed. And I think that a lot of it is still related to the fact that the agenda for energy efficiency has been still too little. Let me put it that way: too little presented as a business case. So we still get a sense that we talk about energy, or you're kind of greenly and let us do our business. So that is a bit the perception there. And I also believe that in a broader sense, we also observe that the notions of efficiency and productivity are somewhat weaker in among the MSME segment in India, and you might even see some cultural or historical factors for that. That we've grown up with the Jugaad kind of manufacturing. That second best is always good, is always still good enough, and this we need to turn around. We've on some other occasion or some other panels, I have actually said we need also something like a productivity drive for manufacturing sector, something like we had for Swachh Bharat for cleaning up the cities, and we need a Swachh Bharat for the MSME sector. So to really drive this as a national priority, and then we need to bring this knowledge very close to the clusters to help them to find the appropriate guidance. And for that we need probably tens of thousands of advisors and auditors coming in.
Thank you. Rene, the next set of questions are in terms of how does India compare, given your experience working in similar economies, both in Asia and Eastern Europe, and particularly your stint now in India, how does India compare with other countries as far as efficiency, the focus towards it, and the importance and the levels at which it is currently at? And in your opinion, what are the areas to focus on? One, of course, you mentioned on a huge drive on productivity. Is there anything else that you suggest we should do systemically, either at the industrial level or at the policy level, in terms of taking the energy efficiency agenda or the resource efficiency agenda forward?
Yeah, I think that it's difficult to compare apples and oranges. So to compare the industrial energy efficiency scenario in India with Indonesia or with Sri Lanka is quite a challenge. I think that in all countries you would see some leaders and some laggards, and in that sense, India is not much behind. I think that what India has done well is to drive energy efficiency in the larger energy segment among the designated consumers, and basically the PET scheme and related issues, and that has trickled on to some of the supply chains and so on. But the challenge is still in the MSME segment, and there it is really still the opportunity, and I don't see that really very much different from the other countries in the region. I think you can't compare with Europe, of course, or with Eastern Europe or with Australia, because of also different pricing, different levels of technology and so on. So one needs to continuously have a drive at this. My sense is very much that we should create more of this, and I come back to what I just said on this productivity and efficiency perspective. So everything we do should have a meaning, or should have a purpose in manufacturing. When we have energy, it's for a purpose. When we employ labor, it's for a purpose. And this is maybe still the biggest challenge that we see. I don't see it immediately as so much an issue of technology. I mean, technology will come once we've done the easy things, but to get more companies involved. So if you have what is it, 60 million MSMEs or so in India, to get the large majority of them who are energy intensive involved, we need to work on digesting this and having bite-sized chunks which speak to the business responsibility and the business opportunity.
Thanks. Rene, you mentioned about the PAT scheme, and Bureau of Energy Efficiency has been leading the way as far as energy efficiency is concerned. The draft policy on resource efficiency talks about a Bureau of Resource Efficiency, or a similar organization which has a focus particularly on resource efficiency to look at in the country. In your opinion, Rene, what are the areas that should focus on? I mean, particularly for the MSME segment, while the current thought on resources has been more on the country level or at a larger industry perspective, an organization like a Bureau of Resource Efficiency, what are the areas it should focus on as far as the small and medium enterprises are concerned?
Yeah, I think a lot of sorry to retrace myself. I think that there's a shortage of data, so we have no good clue. So that would be one strain of work. We need to better understand what is the resource situation in the MSME segment. And for energy, we've started a little bit, but for other resources, this is largely missing. So that would be one component. So to better energy resource mapping and technology assessment. I think then we need to have a focus on the technical solutions which are available at enterprise level, and for this we need to bring it to the cluster level and set up a service ecosystem which can deliver this to the MSMEs. I think what I personally also feel is that for many MSMEs are operating in clusters which we can honestly say are quite polluted. So there's no incentive for that. So why would I clean up my factory if the environment is so polluted around me? So we also need to do something on environmental cleanup around these heavily polluted clusters so that there is an incentive for these enterprises. But we need to bring some data to this, then solutions which are applied and delivered at the doorstep, and then address also some of the concerns that you can't clean up a clean factory in a very polluted area.
Thank you. I think the idea of incentives and penalties lead me to this next question, Rene, on the co-benefits. I mean, you touched upon this in a couple of slides that you covered on the co-benefits that spill over from energy to resource to materials to productivity, and how that has to be seen much more holistically than what it is currently. But I think that is still remaining a challenge both for the industry and in some cases even the policymakers from that perspective, because there are policies which are coming in on individual elements rather than a holistic view. Rene, I mean, is there anything that you could think in terms of how do we make a stronger case for the benefits and the co-benefits to be looked at in synergy with each other, and make a stronger case for its implementation in the MSMEs?
Yeah, I think this is in part is a knowledge and understanding issue. So we get, unfortunately, and I mean, I speak to many energy efficiency professionals, so I have to be careful. But I think that we come in with a very specific focus. We've been asked to look at energy efficiency, and we have maybe a too narrow mind on this, so that we don't see the productivity perspective. So it's easy to run straight to the boiler and not ask the question of why did we need steam in the first place. So I think that this is a question of re-education and so on. I think at the government level, of course, we need more integrated policies with an industry policy or a resource efficiency policy. It's not necessarily. And whether we need a separate bureau for resource efficiency and energy efficiency, I'm undecided on that. We need to ultimately to coordinate and also recognize that there are too many different resources to regulate. So we will have to go more on basically the regulating the back door of the factories, which is where the pollution and the effluents come out, because that will give the incentive ultimately to look inside of the factory and do with the efficiency issue. So I don't have a one size fits all answer, but a lot is about bringing basically this perspective of it's not only energy, it's what counts for a business owner is ultimately the bottom line, and that's determined by productivity. But having said that, I think that much of the mindset of MSMEs is also not yet so much tuned into productivity. It's more like sales and purchase and sales, and then I treat production a bit as a black box. And unless we start unpacking this black box, we don't see the productivity benefits.
Thanks. Rene, you spoke about how systems can actually bring a significant change in the way energy efficiency is looked at. You shared UNIDO's experience in terms of how introduction of energy management systems are bringing in huge benefits in the first year of introduction. And
yes.
You were also involved with introducing a few more systems. I mean, I personally was associated on the material flow cost accounting as one of the innovative ways of looking at the entire resource mapping of the enterprises. What do you think is coming in next? I mean, how far have these systems progressed? Of course, the amount of penetration is still, I mean, there is much more longer way to go. But is there anything else which is coming in the near future? Is there something which is more integrated with materials and energy coming up? Any take on that, Rene, on how MSME should look at it in future?
Yes, I think we call it material flow accounting, the MFCA flow cost accounting, sorry. But I think we can cover energy in that as well. So I think that the standard is, so I don't think that we need something different there for that. So we can, within the existing guidelines, we can cover energy there. And it would be really good to try to bring more of this perception of this knowledge around these tools, that we measure cost as things move through a manufacturing manufacturing line. There is not yet much familiarity with this tool. So I think this is one of the tools that would be very much appropriate for Bureau of Resource Efficiency to vigorously promote. I'm not necessarily say that everybody needs them to go for standardization or so. I think that the UNIDO work has been on the management systems, but the other one is the technical systems like chiller systems, cooling systems, heating systems, and so on. That has been quite useful because there has been a tendency to focus on just a boiler. And then we have an efficient boiler, but how does this steam system overall work? Or we have compressed air systems, we do drop the pressure, why is that necessary, and so on. So these questions of more systematically looking at the systems which which is basically then delivering the energy service that I was also referring to, has proven to be very useful. And ultimately, in many cases, if you just look at the perspective from a service provider, is either into steam traps or in boilers, but looking at the system solution is of course what will help the MSME, and the efficiency of the boiler will only pay if the efficiency of the steam system is there. But that kind of a mindset is not yet there, because overall many manufacturing units are not that well set up, not that well designed, not that well planned. So we're not so much thinking in that. We just we put the equipment there, and then we get a welder to connect some pipes, but we have never really thought about what is the best way forward.
Thank you. And one question that has been coming up repeatedly, Rene, is the MSME's access to finance, particularly for getting these projects implemented. And we know that is one of the big points of discussion, particularly for small and medium enterprises, in terms of where they will put their money. Would it be in terms of expanding their markets, in terms of expanding their outputs, or is it looking at improvements? And more so at a situation where there is no specific, I would say, motivation from the financial institutions as well to work with the MSMEs and improve their performances. The ticket sizes are smaller, the risks associated with them are higher. I mean, you mentioned about your work with EESL in terms of looking at innovative financing options, Rene. Are there any thoughts in terms of how could MSMEs be made more, finance be made more accessible to MSMEs for these interventions?
Yes, I think the work with ESL and DC MSME is really it's actually showing that it shows as a financing problem, but ultimately it's more of a risk issue. So where do I put my money? And if I build a second line, I know I have the control myself that I can sell twice the amount of cookies or biscuits or whatever it is. And if I do it in efficiency, I just have to believe the consultant which is advising this, or the person selling this. And this is a bit of the challenge. So taking out some of the guesswork. So it's more about risk management. So standardizing of the solutions, and working at bulk procurement, which we have shown now in some of the clusters, that 15 to 40% might be possible, which would then quite help. And then what then remains is looking at some specific energy financing instruments like the ESCO, which is an ESL is doing, or partial risk guarantees, which could be done, or maybe also if we can do something with innovative energy bonds, so that a portfolio of energy investments can be guaranteed and can attract some CSR or social responsible investment money, so that there's solutions there. It is more a matter of customizing this. I think for the financial sector, we, including myself, we have always thought that we can train bankers on energy efficiency, but I believe that is maybe not the right approach. Because for them, they will never become an engineer that fully understands, but we need to explain to them that a company can make more money by wasting less. That is as far as it needs to go. And then we need technical people to basically certify that certain levels of energy savings can be achieved. Like they also have in other areas, they take it for granted that you can sell twice the amount of biscuits. So they should also take them for as a level of guarantee that you can make the same biscuits with half the energy, or with a quarter of energy less, or whatever the number is. So I think that it's also a bit on the financial institutions to tune more into this efficiency around.
Thanks, Rene. Thank you. Thanks for your thoughts. I think there are quite a lot of questions, Rene, on industrial symbiosis, on innovation ecosystem in the country, on eco-industrial parks. But I think in the interest of time, I'll skip them. And I think you have managed to create a lot of interest among the participants to look at these areas quite at length. But I mean, we are just at the end of our session, Rene. Maybe I'll just leave the floor to you to give your closing thoughts, to summarize and maybe present your thoughts both in terms of your lecture as well as the questions that came in up for discussion today.
Yeah, I think what I try to repeatedly highlight is that there a lot of knowns are there. So what we can already do, we need to accelerate. For that, we need to break some of the barriers, which a very important one is first that it's not that relevant. It's not that important. So we need to get it, put it higher on the agenda. Then the other one is that I think we are now, we're focused on what is feasible or what we know is proven. And I think that we could benefit from enlarging our horizon, not immediately for investment, but for scoping broader into what is, I call that often conceivable. If we sit around the table, we can figure out ways that we can make this perhaps work, and then we need to do some trials. So being so focused on when do I get this back, and that is of course also with innovation at large. That if we ask on day one what is going to be the payback time and when do I get my money back, then innovation is basically dead before it's born in that sense. So we need to have some innovation ecosystem, and we just 30 seconds. We're also working with DST, Department of Science and Technology, on actually mapping the manufacturing innovation ecosystem and coming up with some solutions. And we see in Europe and other places where I work that where innovation happens it is because research providers, so academia, research institutes have a very good collaboration with the research end users, which could be industry, which is then facilitated by government and the arbitrators, so the IPR institutions and the financial institutions. Lots of issues could not be discussed, but we are available, and some of the resources were there that could be looked up on, and we are happy to take the conversation forward on an individual or with different groups. So thank you very much for the opportunity.
Thanks, Rene. Thanks for your time. Thanks for your address and for taking up the questions and sharing your thoughts. Thank you. And for all the participants, this lecture series will be available on our YouTube channel. Please do feel free to share it with people whom you think could benefit from this program. And look forward to having you again join us at the forthcoming lecture series. Thanks, Rene. Thank you very much.
Thank you. Pleasure.
Thank you.